Welcome. We want to take a brief look at possible solution sets to compound inequalities. Our compound inequalities essentially are going to occur, right? Once we work on solving them, we're going to end up with a couple different possibilities. So let's see here. Possibility one. Let's say we end up with x is less than a, or x is greater than b. And when we have this sort of scenario, we could end up with two different situations. So I guess this is 1a. Um, if a is here and b is here, x being less than a, we would shade all of this. If x is greater than b, we would shade all of this. And so together, our final answer would be that it could be anything to the left of A or anything to the right of B. And life is good. So we could end up with that scenario. The other scenario that we could end up with for x being less than A or greater than B is that we actually have A is over here and that B is over here. So in the case that A is less than B, we end up with these two pieces as our solution set. But when A is greater than B, our final representation, right, if it can be here or here, then anything at all will work because all of this works because of this portion, and all of this works because of this portion. So our interval notation might be negative infinity up to A union B up to infinity. And in this case, we would simply have all real numbers that can be represented as the interval from negative infinity to positive infinity, or by this fancy looking R with two vertical lines here. Again, these are both x less than A or x greater than B. Minute changes necessary if you want to have the inclusion of endpoints there. So that handles our or. The other situation is x. So let's do x is less than A and x is greater than B. So I'll split it up this way here. And so we could have, again, the same sort of scenarios. If A is less than B, so we have everything over here, because x is less than A, x is greater than B. But if I want it to be both of these things, then our final answer when we combine them is nothing, because there's nothing that's here and here, right? We're looking for those overlaps. We're trying to bring these things down. I shade this point because that point above it is shaded. I shade this point because that point above it is shaded, and I can have it from here or there. But now I'm looking for where it's shaded above on both lines. Well, these are only shaded on one line, and these are only shaded on one line. The other scenario that I can have is that, see here, actually I want A to be over here now, and I want B to be over here. So everything less than A, everything greater than B. And now when I bring this down, when I look at those points that are less than A and greater than B, I get all of these things, right? These are both shaded, so that's in there. These are both shaded, so that's in there. I can go as low as B itself and as high as A itself, not inclusive. And everything in between them will work just fine. Here, again, oh look, nothing works. So we can write this in a couple different ways. We can write it as no solution Or let's see here, some books use bracket notation or curly bracket notation, that is, for sets, which is wonderful. List notation, just nothing in the list, nothing in the set. Or we can also use this notation as 0 with a line through it to represent a set with nothing in it. So each of these are perfectly fine. And then in this case, we have the open interval from B to A. Okay, so those are the 4 possibilities for what our solution sets might look like for compound inequalities, right? Again, those compound inequalities, if it wasn't made clear, if you weren't quite following along there, compound inequality simply is referring to having not one but 2 inequalities that are being satisfied, and they're being joined with either an or statement or an and statement. So this or that, this and that. The usual or the expected solution sets are typically this one and this one. However, I did want to emphasize in this presentation, or by giving this presentation, that we could have all real numbers or nothing as solution sets as well. Thank you for your time.